Hello and welcome to my channel. If you've been here before, welcome back. My name is Alfonso Peluso and I'm a Studio Associate Professor in the College of Architecture at IIT, the home of the legendary Mies van der Rohe, and I'm adjunct faculty at Columbia College Chicago in the Interior Architecture program. Shout out to all of my students. I hope you're having a great day. At this point that I'm recording this, it is getting close to the end of the semester, very close to the end of the semester, the fall 2020 semester, a semester that we were all very, I think, maybe a little bit anxious about and worried about how we were going to get through it. But I think we're doing just fine. I think we're getting through it just fine, and it actually went by really fast. Today's tutorial is going to look at Karamba and how to optimize Karamba using a plugin called Biomorpher. And if you haven't used Biomorpher before, go ahead and look at one of my past videos where I explain Biomorpher in detail, and I'll put a link to it at the end of this video as well. So I'm just going to launch Biomorpher here and give myself some room here. Okay, so what I'm searching for is the least amount of deflection in this grid shell structure that I'm looking at. So if I click the go button, you're going to see Biomorpher is going to go through some iterations. And if I go over to designs, it's showing me those designs. And what I can do is I can use performance and I can look at minimizing the amount of deflection. Right now, the minimized or the least amount of deflection is happening where the dots are the smallest. So if I look at 10, if I pull that one back up, that has the least amount of deflection. That one looks pretty good, looks pretty stable. I can check that and I can make more iterations. I can evolve more with that. And we'll get a chance to do this toward the end of our tutorial today. Alright, before we jump into the tutorial, if you haven't subscribed to my YouTube channel, go ahead and search me up on YouTube. Click on the big red block subscribe button and click on the little bell to receive all the notifications. Wouldn't want you to miss out on any videos to help you along with whatever you're doing architecturally. Also, connect with me on Instagram at my first name Alfonso _ my last name Peluso. Would love to hear what you're up to. Come check out what my students have been up to, what I'm up to, what videos I'm making. Like I said, it's been a really great semester and looking forward to the next one. Alright, let's get started on this. I'm just going to delete everything that I have here. Just do a little save as just in case. Okay, what we're going to need is we're going to need a floor and a roof, and we saw that in the little sample that I showed. So I'm going to add a scribble, and this is going to be my floor, and I'm going to make a plane surface. And I'm going to set that, it's important to know the size of that plane surface. I'm going to set that plane surface to 30. So it will be 30 by 30. And the unit's not so important whether it's 30 meters or 30 feet. It's just a unit of 30 for now. That's my floor. And I'm going to copy that up to become my ceiling. Let me get my bifocals going here so you guys know what capsules I'm using. Alright, so I'm going to actually not plug this into motion, but plug this into geometry, and you see that copies up, and I'm going to control that Z height. I'm going to make that 15 in the Z. minimize this a little bit. Okay, so that's going to be my roof. So I'm going to add a scribble for that. Okay, now I'm going to define the column locations, and I've done a few Karamba videos. You should check those out on my YouTube page. I'll link a few of those at the end of this video as well. And I've looked at many different ways to define supports, and in this case I'm calling them column locations. This is the first time I'm going to do it this way. So I'm going to make a scribble. Okay, and these are going to be my column locations. And I'm going to add what's called a gene pool, which is a series of number sliders. And I should say, this tutorial that I'm making this video of, I received inspiration from one of the sample files on Karamba 3D's website. So shout out to Karamba 3D and everything that you guys are doing, and I thought it'd be great to make a video of one of the definitions that I saw on your website. I've simplified it just a bit. Okay, so with this gene pool I can right click and I can randomize it, and I get random numbers. Now what I want to do is I want to make every other value an X value and every other value a Y value. So I have X and Y values. So I'm defining the locations of the columns through X and Y values. I can do this by using a dispatch. And the way dispatch is set up by default is set up true, false, or every other one. So list A is going to list, you'll see every other one. And then list B is every other one starting from the second one. Okay, so I'm going to use a construct point, and list A are my X coordinates and list B are my Y coordinates. So you see some X and Y coordinates. There's a total of 5 of them. They don't fall on my floor or on my roof structure. That's because these values are too large. So I'm going to double click on this and change the maximum. I'm going to change the maximum to 30. Okay, now they are going to sit on my surface. I could also change these from 0 to 1 and then use an evaluate surface like I've done in the past, but I like this way a little bit better. Okay, so those are my locations of my columns. Now what I want to do is I want to turn those into supports. I want to transfer those points to the roof. Okay, so to do that, I'm going to make a mesh out of my roof. I'm going to use the command mesh brep. Okay, and I'm going to change the settings of this mesh brep. I'm going to use a settings command, settings. I'm going to plug that in. Okay, so as of now the minimum count for that is 16, and I'm seeing that that is relatively square. So that's what I'm looking for. If you're not seeing those mesh edges, make sure you're in Grasshopper. You go to the main menu, display, preview mesh edges, or control M for mesh. Okay, so I'm going to leave that. I'm going to put a number slider in there just to remind myself that it's there. That's the minimum count. Okay, so that's looking pretty good. Those are square. Okay, so what I'm trying to do is I'm trying to transfer these points here to the points on the roof. Okay, so I need points on that roof. I don't have any yet, and I can do that by using a deconstruct mesh. And I can go ahead and plug my mesh brep into that. And I'm going to use a point capsule and plug my vertices in. Just a little point container there. Okay, so I'm going to use a capsule called closest point. Closest point. Not closest points, but singular, closest point. Okay, the cloud of points that it's looking to project to are all my roof points, because I want to project to the roof. And the points that it's going to project up to the roof are these construct points. Alright. 2 might be falling in the same location. That's why I'm only seeing 1, 2, 3, 4. But that's okay. We'll deal with that. I can randomize this and see if that helps. 1, 2, 3, 4, 5. Alright. I have all 5 points spread out there. Alright, great. Now we are ready to start the Karamba part. Okay, so we're going to be doing Karamba and Biomorpher. Now we've just set up our geometry. I'd actually like to draw a line just to see these columns. Oops, I'd like to draw a line from these points to all these closest points. Okay, so now you see the columns starting to show up, so you're starting to see our structure. Alright, I'm going to draw a not so straight line here. And we're going to start our Karamba part of the definition. Alright, great. Alright, so I'm going to bring out a capsule from Karamba 3D, which is called Assemble Model. And I'm just going to put that over here. So it's looking for point, element, support, and load. Now we're not going to use point, so we don't have to worry about that. So we need element, support, load. Okay. So element comes from the structure type. Alright, so I'm going to add a scribble. Call this structure type. And we're going to look at 2 structure types today. We're going to look at mesh to shell, and we're going to look at line to beam. Okay, so mesh to shell is the first one we're going to look at. Alright, it's looking for an input of a mesh. So our input of our mesh is coming from our mesh brep. That has the element coming out of it, so I can plug that in. Give myself some room. I know I'm going to need some room here. Okay, so now support. So again, under model, I'm going to choose support. I'm going to turn on all of the radio buttons so that it's free to move and rotate at the support location. It's free to rotate, basically. Okay, so the supports are at all those closest point locations. So I can plug that in there, and I can plug that into support. Alright, last, my load. So I'm going to go up to load and choose loads, and we're going to make this a point load, and I'll plug that into load. And we will make this in the Z direction, and I want it pushing down, so I want this to be in the negative. And I'm going to start with 2.555. Okay, I'm just going to move all this over. All right, we're doing good. The position of the loads, I want that to be at all of my points, so all of those points. All right, that capsule's ready to go. Okay, so we've assembled the model. We need to analyze the model. We'll be using this maximum displacement soon. We need some results for the model, so we need a model view. Right now you'll see it'll start to deform. Okay, deform like crazy because the load is very high at the moment. And lastly, we need a shell view. And if I go under render settings today, since we're looking at displacement, I can change it to displacement, where the darker colors will be where it is displaced more. Okay, let's lower that load down and bring the structure back up. Make it pretty low here. Okay, so something like that, so it's kind of fitting between the roof and the floor. Alright, that's looking pretty good. So now we can use Biomorpher like I did in the beginning of the tutorial. So I'm going to draw a not so straight line here. Add a scribble. So Biomorpher is another one of these evolutionary algorithms that is going to optimize our deflection for us. Okay, so I can find that under parameters, and I can click on the little biomorpher symbol. I don't know if it's like a bird or a fly morphing into a bird. I'm not sure. Maybe someone can help me with that in the comments. Okay, so the geometry. My mesh of rendered shells is coming out of this, and I'm just checking to see if there's one or two or more. Since there's only one, that's fine. That's all I need right now. I'm going to plug that into geometry. I like to make a mesh capsule though. And plug that into geometry. The performance is going to be the deflection. So that's the displacement. And then the genome is going to come all the way over from this gene pool. So I can zoom into it, zoom out, and then zoom into my Biomorpher capsule and plug that in. Alright, so this is ready to go. I'm going to double click on it, move it over a little bit. Alright, so again I mentioned I have a Biomorpher video. I'll put a link to it at the end of this. What I want to turn on right now is show all 12 clusters and cluster centroids in history. And I'm going to click on Go, which just uses a random initial population, or I can click on Go, which creates an initial population from the current parameter state. I'm just going to go with a random one. Alright, let's go over to our designs. Now, right now it's showing me design 0, okay, which is one of these with a minimum displacement because it has the little dots. Let's see what 6 looks like. I can double click on 6. I can double click on 7. 7 looks pretty minimal. It's got this nice where the roof comes down and meets the floor, which is kind of a nice design aesthetic. So I'm going to go with that one, 7. And we'll come back at the end where I'm making the grid shell, and we'll make more iterations and we'll make a history out of it. But what I'm referring to with the history is if I check this one and I click on minimize, now it's going to evolve and make some more iterations based on this number 7, this design 7. So I'll go ahead and evolve this 2 more iterations. Alright, so now I'm getting some nice gentle sloped ones with little deflection based on that design number 7. And if I go to history, I'm seeing the history of these, and I can save that. I'm just saving an image of all those. Alright, I'm going to go ahead and close out of Biomorpher. Okay, so I'm going to now change the structure type. So we're going to look at the structure type. So we're going to change it from a shell to a beam. So I'm going to go into Karamba, and under model I'm going to choose line to beam. Okay, so the lines that I'm changing to beams. So I have this mesh here, and I can change all the mesh edges. So I'll plug that in. Both my naked and my interior edges. And then also my lines for the columns. Okay, those are going to become my beams. Now, I want to give them a cross section. I want to give them an actual size. Okay, so before we do that, let's actually get this structure type in play. So right now the mesh to shell is still in play. So we're going to replace that. I'm going to take element and plug in this one instead. Notice the deflection got way less. Okay, so I can increase this. Okay, so we're getting some more deflection there. Alright, now at the very end, instead of a shell view, we need a beam view. So I'm going to go under results and find my beam view. And I'm going to go ahead and plug that in. Okay. Go under render settings and change it to displacement. Which one's displacement? This is cross-section axial utilization displacement. Okay. Alright, so let's give these a size. Let's give them an actual cross-section. Alright, so under cross-section, I can choose cross-section. And the type of cross-section, I'm just going to use a pipe for right now. And I'll plug that into the cross-section. And I'm going to give that a diameter. Right now it's around 12. So I'm going to type in 25.555. Plug that in. Alright, so now it's strengthened up that grid. So there's really not much deflection happening. Make these a little, as I make them thicker, it becomes stronger. As I make them thinner, they just become like spaghetti. Okay. Alright, so let's just add more load to it. I gave them a thickness. What was my thickness? Around 38. And, sorry for the zooming in and out here. Here's the load. Get this to deflect a little bit. Alright, maybe something like that. And then we'll have Biomorpher find the minimum deflection. Okay, almost done here. So let's get Biomorpher in play. So Biomorpher is already hooked up. The performance is already hooked up to the maximum displacement. It's already hooked up to our genome number sliders. So the geometry needs to switch. So I'm going to plug my meshes of rendered beams into here. And yeah, then we're set. We switched it. Alright, let's go ahead and use Biomorpher to find the minimum deflection. Alright, I'm going to check on show all 12 cluster centroids in history, and I'm just going to click go. Alright, I like that one. That one looks actually really pretty good. If I go to designs, that's actually design 0 that it's showing me. Now these are showing me in color as I zoom in. It's pretty wild. Alright, so based on design 0, I am going to minimize, do some more minimize displacement, and I'm going to add 3 iterations this time. And then I'm going to click on evolve. That's going to run through all of these. So if I go to history, these are showing up in my history now. All the iterations that I could choose, I could look at. These numbers represent deflection. So here's one with only 54 deflection. So that's, it's, as a designer, I think it's not only the minimum deflection, because the winner would be this one, this 18. I can click on this and click reinstate. I was hoping there'd be less deflection than that. It looks like quite a bit of deflection in that one. Oh, there it is. So it's just a matter of double clicking on these. Okay, so that's that one with the 18 deflection on it. And I can save this as a PNG. Alright, I think we covered everything. This is really fantastic. It's a really neat structure, actually. So if you found this video helpful, go ahead and give me a thumbs up. Leave me a comment of why you found the video helpful. Click on my head in the upper left here to subscribe to my channel if you haven't subscribed already. Click in the upper right to go to my Karamba playlist, and click in the lower right to go to my Biomorpher video. I will see you next time.